Chapter 3 of The Red Man's Continent by Ellsworth Huntington. This LibriVox recording is in the public domain. Recording by Jim Locke of Floyd, Virginia. The Geographic Provinces of North America. The four great physical divisions of North America, the Laurentian Highland, the Appalachian Highland, the Plains, and the Western Cordillera, are strikingly different in form and structure. The Laurentian Highland presents a monotonous waste of rough hills, irregular valleys, picturesque lakes, and crooked rivers. Most of it is thinly clothed with pine trees and bushes such as the blueberry and the huckleberry. Yet everywhere the ancient rock crops out. No one can travel there without becoming tiresomely familiar with fine-grained, shattered schists, coarse granites, and their curiously banded relatives, the gneisses. This rocky highland stretches from a little north of the St. Lawrence River to Hudson Bay, around which it laps in the form of a V, and so is known as the Archean V or shield. Everywhere this oldest part of the western hemisphere presents unmistakable signs of great age. The schists, by their fine crumpling and scaly flakes of mineral, show that they were formed deep in the bowels of the earth, for only there could they be subjected to the enormous pressure needed to transform their minerals into sheets as thin as paper. The coarse granites and gneisses proclaim still more clearly that they must have originated far down in the depths of the earth. Their huge crystals of mica, quartz, hornblende, feldspar, and other minerals could never have been formed except under a blanket of rock which almost prevented the original magmas from cooling. The thousands or tens of thousands of feet of rock which once overlay the schists, and still more the granites and gneisses, must have been slowly removed by erosion, for there was no other way to get rid of them. This process must have taken tens of millions of years, and yet the whole work must have been practically completed 100 or perhaps several 100 million years ago. We know this because the self-same ancient eroded surface which is exposed in the Laurentian Highland is found dipping down under the oldest known fossiliferous rocks. Traces of that primitive land surface are found over a large part of the American continent. Elsewhere they are usually buried under later strata, laid down when the continent sank in part below sea level. Only in Laurentia has the land remained steadily above the reach of the ocean throughout the millions of years. Today this old land might be as rich as many others if climate had been kind to it. Its soil, to be sure, would in many parts be sandy because of the large amount of quartz in the rocks. That would be a small handicap, however, provided the soil were scores of feet deep, like the red soil of the corresponding highland in the Guiana region of South America. But today the North American Laurentia has no soil worth mentioning. For some reason not yet understood, this was the part of America where snow accumulated most deeply and where the largest glaciers were formed during the last great glacial period. Not once, but many times its granite surface was shrouded for tens of thousands of years in ice a mile or more thick. As the ice spread outward in almost every direction, it scraped away the soil and gouged innumerable hollows in the softer parts of the underlying rock. It left the Laurentian Highland a land of rocky ribs rising between clear lakes that fill the hollows. The lakes are drained by rapid rivers which wind this way and that in hopeless confusion as they strive to move seaward over the strangely uneven surface left by the ice. Such a land is good for the hunter and trapper. It is also good for the summer pleasure seeker, who would fain grow strong by paddling a canoe. For the man who would make a permanent home, it is a rough, inscrutable region, where one has need of more than most men's share of courage and persistence. Not only did the climate of the past cause the ice to scrape away the soil, but the climate of the present is so cold that even where new soil has accumulated, the farmer can scarcely make a living. Around the borders of the Laurentian highland, the ice accomplished a work quite different from the devastation of the interior. One of its chief activities was the scouring of a series of vast hollows which now hold the world's largest series of lakes. Even the lakes of Central Africa cannot compare with our own Great Lakes and the other smaller lakes which belong to the same series. These additional lakes begin in the far north with Great Bear Lake and continue through Great Slave Lake, Lake Athabasca, and Lake Winnipeg to the Lake of the Woods not far from Lake Superior. All these lakes lie on the edge of the great Laurentian shield, where the ice, crowding down from the highland to the north and east, was compressed into certain already existent hollows, which it widened and deepened, and left as vast bowls ready to be filled with lakes. South and southwest of the Laurentian highland, the great ice sheet proved beneficial to man. There, instead of leaving the rock naked, as in the Laurentian region, it merely smoothed off many of the irregularities of the surface and covered large areas with the most fertile soil. In doing this, to be sure, the ice cap scoured some hollows and left a vastly larger number of basins surrounded in whole or in part by glacial debris. These have given rise to the innumerable lakes, large and small, whose beauty so enhances the charms of Canada, New England, New York, Minnesota, and other states. They serve as reservoirs for the water supply of towns and power plants and as sources of ice and fish. Though they take land from agriculture, they probably add to the life of the community as much in other ways as they detract in this. Moreover, glaciation diverted countless streams from their old courses and made them flow over falls and rapids from which water power can easily be developed. That is one reason why glaciated New England contains over 40% of all the developed water power in the United States. Far more important, however, than the glacial lakes and rivers is the fertile glacial soil. It comes fresh from the original rocks and has not yet been exhausted by hundreds of thousands of years of weathering. It also has the advantage of being well mixed, for generally it is the product of scrapings from many kinds of rocks, each of which contributes its own particular excellence to the general composition. Take Wisconsin as an example. Most parts of that state have been glaciated, but in the southwest there lies what is known as the driftless area, because it is not covered with the drift or glacial debris which is thickly strewn over the rest of the state. A comparison of otherwise similar counties lying within and without the driftless area shows an astonishing contrast. In 1910, the average value of all the farmland in 20 counties covered with drift amounted to $56.90 per acre. In 6 counties, partly covered with drift and partly driftless, the value was $59.80 per acre, while in 13 counties in the driftless area it was only $33.30 per acre. In spite of the fact that glaciation causes swamps and lakes, the proportion of land cultivated in the glaciated areas is larger than in the driftless. In the glaciated area, 61% of the land is improved, and in the driftless area, only 43.5%. Moreover, even though the underlying rock and the original topography be of the same kind in both cases, the average yield of crops per acre is greater where the ice has done its work. Where the country rock consists of limestone, which naturally forms a rich soil, the difference in favor of the glaciated area amounts to only 1 or 2%. Where the country rock is sandy, the soil is so much improved by a mixture of fertilizing limestone, or even of clay and other materials, that the average yield of crops per acre in the glaciated areas is a third larger than in the driftless. Taking everything into consideration, it appears that the ancient glaciation of Wisconsin increases the present agricultural output by from 20 to 40%. Upwards of 10,000,000 acres of glaciated land have already been developed in the most populous parts of the State. If the average value of all products on this area is reckoned at $15 per acre, and if the increased value of agricultural products due to glaciation amounts to 30%, then the net value of glaciation per year to the farmers of Wisconsin is $45,000,000. This means about $300 for each farmer in the glaciated area. Wisconsin is by no means unique. In Ohio, for instance, there is also a driftless area. It lies in the southeast along the Ohio River. The difference in the value of the farm land there and in the glaciated region is extraordinary. In the driftless area, the average value per acre in 1910 was less than $24, while in the glaciated area it was nearly $64. Year by year, the proportion of the population of the State in the unglaciated area is steadily decreasing. The difference between the two parts of the State is not due to the underlying rock structure or to the rainfall, except to a slight degree. Some of the difference is due to the fact that important cities, such as Cleveland and Toledo, lie on the fertile level strip of land along the lake shore, but this strip itself, as well as the lake, owes much of its character to glaciation. It appears, therefore, that in Ohio, perhaps even more than in Wisconsin, man prospers most in the parts where the ice has done its work. We have taken Wisconsin and Ohio as examples, but the effect of glaciation in those states does not differ materially from its effect all over southern Canada and the northern United States, from New England to Kansas and Minnesota. Each year the people of these regions are richer by perhaps $1 billion because the ice scraped its way down from Laurentia and spread out over the borders of the Great Plains on the west and of the Appalachian region on the east. We have considered the Laurentian highland and the glaciation which centered there. Let us now turn to another highland, only the northern part of which was glaciated. The Appalachian highland, the second great division of North America, consists of 3 parallel bands which extend southwestward from Newfoundland and the St. Lawrence River to Georgia and Alabama. The eastern and most important band consists of hills and mountains of ancient crystalline rocks, somewhat resembling those of the Laurentian highland, but by no means so old. West of this comes a broad valley, eroded for the most part in the softer portions of a highly folded series of sedimentary rocks, which are of great age, but younger than the crystalline rocks to the east. The third band is the Alleghany Plateau, composed of almost horizontal rocks, which lie so high and have been so deeply dissected that they are often called mountains. The 3 Appalachian bands by no means preserve a uniform character throughout their entire length. The eastern crystalline band has its chief development in the northeast. There it comprises the whole of New England and a large part of the maritime provinces of Canada, as well as Newfoundland. Its broad development in New England causes that region to be one of the most clearly defined natural units of the United States. Ancient igneous rocks, such as granite, lie intricately mingled with old and highly metamorphosed sediments. Since some of the rocks are hard and others soft, and since all have been exposed to extremely long erosion, the topography of New England consists typically of irregular masses of rounded hills free from precipices. Here and there hard masses of unusually resistant rock stand up as isolated rounded heights, like Mount Katahdin in Maine. They are known as monadnocks, from the mountain of that name in southern New Hampshire. In other places larger and more irregular masses of hard rock form mountain groups like the White Mountains, the Green Mountains, and the Berkshires, each of which is merely a great series of monadnocks. In the latitude of southern New York the crystalline rocks are compressed into narrow compass and lose their mountainous character. They form the irregular hills on which New York City itself is built, and which make the suburbs of Westchester County along the eastern Hudson so diverse and beautiful. To the southeast the topography of the old crystalline band becomes still less pronounced, as may be seen in the rolling fertile hills around Philadelphia. Farther south the band divides into two parts, the mountains proper and the Piedmont Plateau. The mountains begin at the Blue Ridge, which in Virginia raises its even-topped heights mile after mile across the length of that State. In North Carolina, however, they lose their character as a single ridge and expand into the broad mass of the southern Appalachians. There Mount Mitchell dominates the eastern part of the American continent and is surrounded by over 30 other mountains rising to a height of at least 6,000 feet. The Piedmont Plateau, which lies at the eastern foot of the Blue Ridge, is not really a plateau but a peneplain, or ancient lowland, worn almost to a plain. It expands to a width of 100 miles in Virginia and the Carolinas, and forms the part of those States where most of the larger towns are situated. Among its low, gentle heights there rises an occasional little monadnock like Chapel Hill, where the University of North Carolina lies on a rugged eminence which strikingly recalls New England. For the most part, however, the hills of the Piedmont region are lower and more rounded than those in the neighborhood of Philadelphia. The country thus formed has many advantages, for it is flat enough to be used for agriculture, and yet varied enough to be free from the monotony of the level plains. The prolonged and broken inner valley forming the second band of the Appalachians was of some importance as a highway in the days of the Indians. Today the main highways of traffic touch it only to cross it as quickly as possible. From Lake Champlain it trends straight southward in the Hudson Valley until the Catskills have been passed. Then, while the railroads and all the traffic go on down the gorge of the Hudson to New York, the valley swings off into Pennsylvania, past Scranton, Wilkes-Barre, and Harrisburg. There the underlying rock consists of a series of alternately hard and soft layers which have been crumpled up much as one might wrinkle a rug with one's foot. The pressure involved in the process changed and hardened the rocks so much that the coal which they contain was converted into anthracite, the finest coal in all the world, and the only example of its kind. Even the famous Welsh coal has not been so thoroughly hardened. During a long period of erosion the tops of the folded layers were worn off to a depth of thousands of feet, and the whole country was converted into an almost level plain. Then, in the late geological period, known as the early Tertiary, the land was lifted up again, and once more erosion went on. The soft rocks were thus etched away until broad valleys were formed. The hard layers were left as a bewildering succession of ridges with flat tops. A single ridge may double back and forth so often that the region well deserves the old Indian name of the Endless Mountains. Southwestward the valley grows narrower, and the ridges which break its surface become straighter. Everywhere they are flat-topped, steep-sided, and narrow, while between them lie parts of the main valley floor, flat and fertile. Here in the south, even more clearly than in the north, the valley is bordered on the east by the sharply upstanding range of the crystalline Appalachians, while on the west, with equal regularity, it comes to an end in an escarpment which rises to the Alleghany Plateau. This plateau, the third great band of the Appalachians, begins on the south side of the Mohawk Valley. To the north its place is taken by the Adirondacks, which are an outlier of the great Laurentian area of Canada. The fact that the outlier and the plateau are separated by the low strip of the Mohawk Valley makes this the one place where the highly complex Appalachian system can easily be crossed. If the Alleghany Plateau joined the Adirondacks, Philadelphia instead of New York would be the greatest city of America. Where the plateau first rises on the south side of the Mohawk, it attains heights of 4,000 feet in the Catskill Mountains. We think of the Catskills as mountains, but their steep cliffs and table-topped heights show that they are really the remnants of a plateau, the nearly horizontal strata of which have not yet been worn away. Westward from the Catskills, the plateau continues through central New York to western Pennsylvania. Those who have traveled on the Pennsylvania Railroad may remember how the railroad climbs the escarpment at Altoona. Farther east, the train has passed alternately through gorges cut in the parallel ridges and through fertile open valleys forming the main floor of the inner valley. Then it winds up the long ascent of the Alleghany front in a splendid horseshoe curve. At the top, after a short tunnel, the train emerges in a wholly different country. The valleys are without order or system. They wind this way and that. The hills are not long ridges, but isolated bits left between the winding valleys. Here and there beds of coal blacken the surface, for here we are among the rocks from which the world's largest coal supply is derived. Since the layers lie horizontally and have never been compressed, the same material which in the inner valley has been changed to hard, clean-burning anthracite here remains soft and smoky. In its southwestern continuation through West Virginia and Kentucky to Tennessee, the plateau maintains many of its Pennsylvanian characteristics, but it now rises higher and becomes more inaccessible. The only habitable portions are the bottoms of the valleys, but they are only wide enough to support a most scanty population. Between them most of the land is too rough for anything except forests. Hence the people who live at the bottoms of the valleys are strangely isolated. They see little or nothing of the world at large, or even of their neighbors. The roads are so few and the trails so difficult that the farmers cannot easily take their produce to market. Their only recourse has been to convert their bulky corn into whiskey, which occupy little space in proportion to its value. Since the mountaineer has no other means of getting ready money, it is not strange that he has become a moonshiner, and has fought bitterly for what he genuinely believed to be his rights in that occupation. Education has not prospered on the plateau because the narrowness of the valleys causes the population to be too poor and too scattered to support schools. For the same reason, feuds grow up. When people live by themselves, they become suspicious. Not being used to dealing with their neighbors, they suspect the motives of all but their intimate friends. Moreover, in those deep valleys, with their steep sides and their general inaccessibility, laws cannot easily be enforced, and therefore each family takes the law into its own hands. Today, the more rugged parts of the Appalachian system are chiefly important as a hindrance to communication. On the Atlantic slope of the old crystalline band there are great areas of gentle relief where an abundant population can dwell. Westward on the edges of the plateau and the plains beyond, a still greater population can find a living, but in the intervening space there is opportunity for only a few. The great problem is to cross the mountains as easily as possible. Each accessible crossing place is associated with a city. Boston, as well as New York, owes much to the low Mohawk-Hudson route, but is badly handicapped because it has no easy means of crossing the eastern crystalline band. Philadelphia, on the other hand, benefits from the fact that in its vicinity the crystallines are low and can readily be crossed even without the aid of the valleys of the Delaware and Schuylkill rivers. It is handicapped, however, by the Alleghany escarpment at Altoona, even though this is lower there than farther south. Baltimore, in the same way, owes much of its growth to the easy pathways of the Susquehanna on the north and the Potomac on the south. Farther south, both the crystalline band and the Alleghany plateau become more difficult to traverse, so that communication between the Atlantic coast and the Mississippi Valley is reduced to small proportions. Happy is New York in its situation, where no one of the three bands of the Appalachians opposes any obstacle. The plains of North America form the third of the four main physical divisions of the continent. For the most part they lie between the great western cordillera on one side and the Laurentian and Appalachian highlands on the other. Yet they lap around the southern end of the Appalachians and run far up the Atlantic coast to New York. They remained beneath the sea till a late date, much later than the other three divisions. They were not, however, covered with deep water, like that of the abysmal oceans, but only with shallow seas from which the land at times emerged. In spite of the old belief to the contrary, the continents appear to be so permanent that they have occupied practically their present positions from the remotest geological times. They have moved slowly up and down, however, so that some parts have frequently been submerged, and the plains are the parts that remained longest under water. The plains of North America may be divided into four parts according to the character of their surface: the Atlantic coastal plain, the prairies, the northwestern peneplain, and the southwestern high plains. The Atlantic coastal plain lies along the Atlantic coast from New York southward to Florida and Alabama. It also forms a great embayment up the Mississippi Valley as far as the Ohio River, and it extends along the shore of the Gulf of Mexico to the Rio Grande. The chief characteristic of this Atlantic and Gulf coastal plain is its belted nature. One layer of rocks is sandy, another consists of limestone, and a third of clay. When uplifted and eroded, each assumes its own special topography and is covered with its own special type of vegetation. Thus in South Carolina and Georgia the crystalline Piedmont band of the Appalachian province is bordered on the southeast by a belt of sandstone. This rock is so far from the sea and has been raised so high above it that erosion has converted it into a region of gentle hills whose tops are 600 or 700 feet above sea level. Its sandy soil is so poor that farming is difficult. The hills are largely covered with pine, yielding tar and turpentine. Farther seaward comes a broad band of younger rock, which forms a clayey soil, or else a yellow sandy loam. These soils are so rich that splendid cotton crops can be raised, and hence the region is thickly populated. Again there comes a belt of sand, the so-called pine barrens, which form a poor section about 50 miles inland from the coast. Finally, the coastal belt itself has emerged from beneath the sea so recently and lies so nearly at sea level that it has not been greatly eroded and is still covered with numerous marshes and swamps. The rich soil and the moisture are good for rice, but the region is so unhealthy and so hard to drain that only small parts are inhabited. Elsewhere in the coastal plain this same belted character is more or less evident. It has much to do with all sorts of activities from farming to politics. On consulting the map showing the cotton production of the United States in 1914, one notices the two dark bands in the southeast. One of them, extending from the northwestern part of South Carolina across Georgia and Alabama, is due to the fertile soil of the Piedmont region. The other, lying nearer the sea, begins in North Carolina and extends well into Alabama before it swings around to the northwest toward the area of heavy production along the Mississippi. It is due to the fertile soil of that part of the coastal plain known as the Cotton Belt. Portions of it are called the Black Belt, not because of the colored population, but because of the darkness of the soil. Since this land has always been prosperous, it has regularly been conservative in politics. The Atlantic coastal plain is by no means the only part of the United States where the fertility of the soil is the dominant fact in the life of the people. Because of their rich soil, the prairies, which extend from western Ohio to the Missouri River and northward into Canada, are fast becoming the most steadily prosperous part of America. They owe their surpassing richness largely to glaciation. We have already seen how the coming of the ice sheet benefited the regions on the borders of the old Laurentian highland. This same benefit extended over practically the whole of what are now the prairies. Before the advent of the ice, the whole section consisted of a broadly banded coastal plain, much older than that of the Atlantic coast. When the ice, with its burden of material scraped from the hills of the north, passed over the coastal plain, it filled the hollows with rich new soil. The icy streams that flowed out from the glaciers were full of fine sediment, which they deposited over enormous flood plains. During dry seasons the winds picked up this dust and spread it out still more widely, forming the great banks of yellow loess, whose fertile soil mantles the sides of many a valley in the Mississippi basin. Thus glaciers, streams, and winds laid down 10, 20, 50, or even 100 feet of the finest, most fertile soil. We have already seen how much the soil was improved by glaciation in Wisconsin and Ohio. It was in the prairie states that this improvement reached a maximum. The soil there is not only fine grained and free from rocks, but it consists of particles brought from widely different sources and is therefore full of all kinds of plant foods. In most parts of the world a fine grained soil is formed only after a prolonged period of weathering, which leaches out many valuable chemical elements. In the prairies, however, the soil consists largely of materials that were mechanically ground to dust by the ice without being exposed to the action of weathering. Thus they have reached their present resting places without the loss of any of their original plant foods. When such a soil is found with a climate which is good for crops and which is also highly stimulating to man, the combination is almost ideal. There is some justification for those who say that the north central portion of the United States is more fortunate than any other part of the earth. Nowhere else, unless in Western Europe, is there such a combination of fertile soil, fine climate, easy communication, and possibilities for manufacturing and commerce. Iron from that outlier of the Laurentian highland, which forms the peninsula of northern Michigan, can easily be brought by water almost to the center of the prairie region. Coal in vast quantities lies directly under the surface of this region, for the rock of the ancient coastal plain belongs to the same Pennsylvanian series which yields most of the world's coal. Here man is indeed blessed with resources and opportunities scarcely equaled in any other part of the world, and finds the only drawbacks to be the extremes of temperature in both winter and summer, and the remoteness of the region from the sea. Because of the richness of their heritage and because they live safely protected from threats of foreign aggression, the people who live in this part of the world are in danger of being slow to feel the currents of great world movements. The western half of the plains of North America consists of two parts, unlike either the Atlantic coastal plain or the prairies. From South Dakota and Nebraska northward far into Canada and westward to the Rocky Mountains there extends an ancient peneplain, worn down to gentle relief by the erosion of millions of years. It is not so level as the plains farther east, nor so low. Its western margin reaches heights of 4,000 or 5,000 feet. Here and there, especially on the western side, it rises to the crest of a rugged escarpment, where some resistant layer of rocks still holds itself up against the forces of erosion. Elsewhere its smooth surfaces are broken by lava-capped mesas, or by ridges where some ancient volcanic dike is so hard that it has not yet been worn away. The soil, though excellent, is thinner and less fertile than in the prairies. Nevertheless, the population might in time become as dense and prosperous as almost any in the world, if only the rainfall were more abundant and good supplies of coal were not quite so far away. Yet in spite of these handicaps, the northwestern peneplain, with its vast open stretches, its cattle, its wheat, and its opportunities, is a most attractive land. South of Nebraska and Wyoming, the high plains, the last of the four great divisions of the plains, extend as far as western Texas. These, like the prairies, have been built up by deposits brought from other regions. In this case, however, the deposits consist of gravel, sand, and silt, which the rivers have gradually washed out from the Rocky Mountains. As the rivers have changed their courses from one bed to another, layer after layer has been laid down to form a vast plain like a gently sloping beach, hundreds of miles wide. In most places the streams are no longer building this up. Frequently they have carved narrow valleys hundreds of feet deep in the materials which they formerly deposited. Elsewhere, however, as in western Kansas, most of the country is so flat that the horizon is like that of the ocean. It seems almost incredible that at heights of 4,000 or 5,000 feet the plains can still be so wonderfully level. When the grass is green, when the spring flowers are at their best, it would be hard to find a picture of greater beauty. Here the buffalo wandered in the days before the white man destroyed them. Here today is the great cattle region of America. Here is the region where the soul of man is filled with the feeling of infinite space. To the student of land forms there is an ever-present contrast between those due directly to the processes which build up the earth's surface and those due to the erosive forces which destroy what the others have built. In the great plains of North America, two of the divisions, that is, the Atlantic coastal plain of the southeast and the peneplain of the northwest, owe their present form to the forces of erosion. The other two, that is, the prairies and the high plains, still bear the impress of the original processes of deposition and have been modified to only a slight extent by erosion. A similar but greater contrast separates the mountains of eastern North America and those of the western Cordillera, the fourth and last of the main physical divisions of the continent. In both the Laurentian and the Appalachian highlands, the eastern mountains show no trace of the original forms produced by the faulting of the crust or by volcanic movements. All the original distinctive topography has been removed. What we see today is the product of erosion working upon rocks that were thousands of feet beneath the surface when they were brought to their present positions. In the western Cordillera, on the contrary, although much of the present form of the land is due to erosion, a vast amount is due directly to so-called tectonic activities, such as the breaking of the crust, the pouring out of molten lavas, and the bursting forth of explosive eruptions. The character of these tectonic activities has differed widely in different parts of the Cordillera. A broad upheaval of great blocks of the earth's crust without tilting or disturbance has produced the plateaus of Arizona and Utah. The gorges that have been rapidly cut into such great upheaved blocks form part of the world's most striking scenery. The Grand Canyon of the Colorado, with its tremendous platforms, mesas, and awe-inspiring cliffs, could have been formed in no other way. Equally wonderful are some of the narrow canyons in the broadly upheaved plateaus of southern Utah, where the tributaries of the Virgin and other rivers have cut red or white chasms thousands of feet deep and so narrow that at their bottoms perpetual twilight reigns. It is a curious proof of the fallibility of human judgment that these great gorges are often cited as the most striking examples of the power of erosion. Wonderful as these gorges certainly are, the Piedmont Plain or the northwestern peneplain are far more wonderful. Those regions had their Grand Canyons once upon a time, but now erosion has gone so far that it has reduced the whole area to the level of the bottoms of the gorges. Though such a fate is in store for all the marvelous scenery of the Western Cordillera, we have it, for the present at least, as one of the most stimulating panoramas of our American environment. No man worthy of the name can sit on the brink of a great canyon or gaze up from the dark depths of a gorge without a sense of awe and wonder. There, as in few other places, nature shows with unmistakable grandeur the marvelous power and certainty with which her laws work out the destiny of the universe. In other parts of the great American Cordillera, some of the simplest and youngest mountain ridges in the world are found. In southern Oregon, for example, lava blocks have been broken and uplifted, and now stand with steep, fresh faces on one side, and with the old surface inclining more gently on the other. Tilted blocks on a larger scale and much more deeply carved by erosion are found in the lofty St. Elias Mountain of Alaska, where much of the erosion has been done by some of the world's greatest glaciers. The western slope of the Wasatch Mountains facing the desert of Utah is the wall of a huge fracture, as is the eastern face of the Sierra Nevadas facing the deserts of Nevada. Each of these great faces has been deeply eroded. At the base, however, recent breaking and upheaval of the crust have given rise to fresh uneroded slopes. Some take the form of triangular facets, where a series of ridges has been sliced across and lifted up by a great fault. Others assume the shape of terraces, which sometimes continue along the base of the mountains for scores of miles. In places they seem like bluffs cut by an ancient lake, but suddenly they change their altitude or pass from one drainage area to another as no lake-formed strand could possibly do. In other parts of the Cordillera, mountains have been formed by a single arching of the crust without any breaking. Such is the case in the Uinta Mountains of northwestern Utah and in some of the ranges of the Rocky Mountains in Colorado. The Black Hills of South Dakota, although lying out in the plains, are an example of the same kind of structure and really belong to the Cordillera. In them the layers of the earth's crust have been bent up in the form of a great dome. The dome structure, to be sure, has now been largely destroyed, for erosion has long been active. The result is that the harder strata form a series of concentric ridges, while between them are ring-shaped valleys, one of which is so level and unbroken that it is known to the Indians as the race course. In other parts of the Cordillera, great masses of rock have been pushed horizontally upon the tops of others. In Montana, for example, the strata of the plains have been bent down and overridden by those of the mountains. These are only a few of the countless forms of breaking, faulting, and crumpling which have given to the Cordillera an almost infinite variety of scenery. The work of mountain building is still active in the western Cordillera, as is evident from such an event as the San Francisco earthquake. In the Owens Valley region in southern California, the gravelly beaches of old lakes are rent by fissures made within a few years by earthquakes. In other places, fresh terraces on the sides of the valley mark the lines of recent earth movements, while newly formed lakes lie in troughs at their base. These Owens Valley movements of the crust are parts of the stupendous uplift which has raised the Sierra Nevada to heights of over 14,000 feet a few miles to the west. Along the fault line at the base of the mountains there runs for over 250 miles the world's longest aqueduct, which was built to relieve Los Angeles from the danger of drought. It is a strange irony of fate that so delicate and so vital an artery of civilization should be forced to lie where a renewal of earthquake movements may break it at any time. Yet there was no other place to put it, for in spite of man's growing control of nature, he was forced to follow the topography of the region in which he lived and labored. On the southern side of the Mojave Desert, a little to the east of where the Los Angeles Aqueduct crosses the mountains in its southward course, the record of an earthquake is preserved in unique fashion. The steep face of a terrace is covered with trees 40 or 50 years old. Near the base the trees are bent in peculiar fashion. Their lower portions stand at right angles to the steeply sloping face of the terrace, but after a few feet the trunks bend upward and stand vertically. Clearly, when these trees were young, the terrace was not there. Then an earthquake came. One block of the earth's crust was dropped down while another was raised up. Along the dividing line a terrace was formed. The trees that happened to stand along the line were tilted and left in a slanting position on the sloping surface between the two parts of the earth's crust. They saw no reason to stop growing, but turning their tips toward the sky, they bravely pushed upward. Thus they preserve in a striking way the record of this recent movement of the earth's crust. Volcanoes as well as earth movements have occurred on a grand scale within a few hundred years in the cordillera. Even where there is today no visible volcanic activity, recent eruptions have left traces as fresh as if they had occurred but yesterday. On the borders of the Grand Canyon of the Colorado one can see not only fresh cones of volcanic ash, but lava which has poured over the edges of the cliffs and hardened while in the act of flowing. From Orizaba and Popocatépetl in Mexico through Mount San Francisco in Arizona, Lassen Peak and Mount Shasta in California, Mount Rainier with its glaciers in the Cascade Range of Washington, and Mount Wrangell in Alaska, the cordillera contains an almost unbroken chain of great volcanoes. All are either active at present or have been active within very recent times. In 1912, Mount Katmai, near the northwestern end of the volcanic chain, erupted so violently that it sent dust around the whole world. The presence of the dust caused brilliant sunsets, second only to those due to Krakatoa in 1883. It also cut off so much sunlight that the effect was felt in measurements made by the Smithsonian Institution in the French provinces of North Africa. In earlier times, throughout the length of the cordillera, great masses of volcanic material were poured out to form high plateaus like those of southern Mexico or of the Columbia River in Oregon. In Utah, some of these have been lifted up so that heavy caps of lava now form isolated sheets topping lofty plateaus. There the lowland shepherds drive their sheep in summer and live in absolute isolation for months at a time. There, as everywhere, the cordillera bears the marks of mountains in the making, while the mountains of eastern America bear the marks of those that were made when the world was young. The geysers and hot springs of the Yellowstone are another proof of recent volcanic activity. They owe their existence to hot rocks which lie only a little way below the surface and which not long ago were molten lava. The terraces and platforms built by the geysers are another evidence that the cordillera is a region where the surface of the earth is still being shaped into new forms by forces acting from within. The physical features of the country are still in process of construction. In spite of the importance of the constructive forces which are still building up the mountains, much of the finest scenery of the cordillera is due to the destructive forces of erosion. The majestic Columbia Canyon, like others of its kind, is the work of running water. Glaciers also have done their part. During the glacial period, the forces which control the paths of storms did not give to the Cordillera region such an abundance of snow as was sifted down upon Laurentia. Therefore, no such huge continental glaciers have flowed out over millions of square miles of lower country. Nevertheless, among the mountains themselves, the ice gouged and scraped and smoothed, and at its lower edges deposited great moraines. Its work today makes the cliffs and falls of the Yosemite one of the world's most famous bits of scenery. This scenery is young, and its beauty will pass in a short time, as geology counts the years, for in natural scenery as in human life, it is youth that makes beauty. The canyons, waterfalls, and geysers of the Cordillera share their youth with the lakes, waterfalls, and rapids due to recent glaciation in the east. Nevertheless, though youth is the condition of most striking beauty, maturity and old age are the condition of greatest usefulness. The young Cordillera, with its mountains still in the making, can support only a scanty population, whereas the old eastern mountains, with the lines of long life engraved upon every feature, open their arms to man and let him live and prosper. It is not enough that we should picture merely the four divisions of the land of our continent. We must see how the land meets the sea. In low latitudes in both the Old World and the New, the continents have tended to emerge farther and farther from the sea during recent geological times. Hence, on the eastern side of both North and South America, from New Jersey to Brazil, the ocean is bordered for the most part by coastal plains, uplifted from the sea only a short time ago. On the mountainous western side of both continents, however, the sea bottom shelves downward so steeply that its emergence does not give rise to a plain, but merely to a steep slope on which lie a series of old beaches several hundred and even 1,000 feet above the present shore line. Such conditions are not favorable to human progress. The coastal plains produced by uplift of the land may be fertile and may furnish happy homes for man, but they do not permit ready access to the sea because they have no harbors. The chief harbor of Mexico at Vera Cruz is merely a little nick in the coastline and could never protect a great fleet, even with the help of its breakwater. Where an enterprising city like Los Angeles lies on the uplifted Pacific coast, it must spend millions in wresting a harbor from the very jaws of the sea. In high latitudes in all parts of the world, the land has recently been submerged beneath the sea. In some places, especially those like the coasts of Virginia and central California, which lie in middle latitudes, a recent slight submergence has succeeded a previous large emergence. Wherever such sinking of the land has taken place, it has given rise to countless bays, gulfs, capes, islands, and fjords. The ocean water has entered the valleys and has drowned their lower parts. It has surrounded the bases of hills and left them as islands. It has covered low valleys and has created long sounds where traffic may pass with safety even in great storms. Though much land has thus been lost which would be great for agriculture, commerce has been wonderfully stimulated. Through Long Island Sound there pass each day hundreds of boats, which again and again would suffer distress and loss if they were not protected from the open sea. It is no accident that of the 8 largest metropolitan districts in the United States, 5 have grown up on the shores of deep inlets, which are due to the drowning of valleys. Nor must the value of scenery be forgotten in a survey such as this. Year by year we are learning that in this restless, strenuous American life of ours, vacations are essential. We are learning, too, that the love of beauty is one of nature's greatest healers. Regions like the coast of Maine and Puget Sound, where rugged land and life-giving ocean interlock, are worth untold millions because of their inspiring beauty. It is indeed marvelous that in the latitude of the northern United States and southern Canada so many circumstances favorable to human happiness are combined. Fertile soil, level plains, easy passage across the mountains, coal, iron, and other metals embedded in the rocks, and a stimulating climate all shower their blessings upon man. And with all these blessings goes the advantage of a coast which welcomes the mariner and brings the stimulus of foreign lands, while at the same time it affords rest and inspiration to the toilers here at home. CHAPTER IV. Recording by Jim Lock of Floyd, Virginia.